Okay, let's get started. Welcome, everyone. This is AI Frontiers Forum. My name is Junling Hu. So today we are going to talk about AI agent. Now, our meetup has received some um, interruption before. So in the beginning of the meetup, all the voice is muted and video are disabled. But at the end of the talk, we can be more interactive. So I will answer questions at the end of this talk. All right. So for today's talk, let me first give you a high-level explanation on agent. Then we will talk about, I will go into the code and see how we can actually build the AI agent. All right, so let me actually put this in a presentation mode. All right. So, I mean, everywhere you turn, there is a new agent coming up. There's a co-pilot and coding agent. The agent that does research scientist, all kinds of things. So really, we would like to understand what is agent, how and each of us can actually take advantage of that and build that. Certainly, many of you have seen like a Hugging Face, OpenAI, they all released the so-called agent framework, but and all of them has a different language, different kind of framework. So it's kind of still very mysterious for most of us to see what exactly is going on. So what I would like to do is really just go under the hood to, without using any framework, to actually understand exactly how an agent was constructed and how it's built. So all right. The basically what when we have time, I will cover most of the topic related to agent. First, what's inside each agent? What are the major components? Secondly, is the most fundamental feature for agent make it different from large language model or just a chat is it can use tools. And then we have certain kind of reasoning capabilities inside the so-called agent. So that make it also more intelligent than just a chatbot. In addition to that, the agent has memory, and it has some history. It knows about the current context in the conversation. Also, may have context about the user from the past experience. And then the agent itself, when it plans out how it actually execute the actions, how it actually interact. Finally, we see a lot of so-called multi-agent system. So I will touch on that. And after that, I will talk a little bit about guardrail and the evaluation. And certainly that is also ongoing topic, very interesting and very important too. All right. Now, the reason in the high level from reinforcement learning framework. So what I would like us to see is there's two different concepts. One is classical agent. Another is now we call the large language LM agent. And everything we talk about today, the most advanced features, all the co-pilot, they're all driven by large language model. So that we are building a large language model agent. However, I think sooner or later, these two framework will converge. That's mainly because it's the most universal framework that in the future we can potentially to right now, agent is very ad hoc. I will explain why is that the case. But so before we get into very specific way to build agent, I still want us to have this high level view carrying from traditional AI, from reinforcement learning, and this high level view will still be valid even for the next 6 months, we will build a very specific large language model agent. But I think next year the whole field probably will come back to this framework. Um, So in terms of when we talk about the reason I want to use this framework, this is much more general to describe how an intelligent being, an agent essentially is something sit in the middle, interact with the environment, and observe what is happening. So you can think about large language model itself is a agent in that sense. A robot is an agent. So everything in the future essentially will condense to this model. Now, the reason I'm saying that is um, if you look at this software development agent, looks like a different kind of interface. It's different from what we consider it's different from this model that I described, but I will explain why we can put that into that framework. So a software development agent essentially has a chat on the side, make a conversation with the user. On the right side, it display the output, the code to the user, and then at the bottom, it can execute on the code. And during that time, this agent will interact with the GitHub repo. It can go out to do a search. It can do many things. And if it's smart, just one button or just one command, you can generate many files in the hierarchical way. So now we basically reach the point that they can build the whole repository with just one sentence, right? So agent has become super intelligent. But if you take a step back to look at what exactly is a software development agent, essentially can be described in this high-level framework. One is the state, the observation, where include the user command, so all the tokens from the user, include all the contexts where which repository the user refers to, where the user work from. And so all these are we call context, or the observation, or another word is a state. So given the state, given the current the agent would observe, then the agent can take action. So on the right side, the agent can have many possible actions. For example, the agent can execute the code inside a Docker sandbox, or it can actually go out to the internet to fetch something back. It can execute the command in the shell. It can also do some Python, run a Python notebook, and keep interacting. So after the agent takes action, the it will send back the result, and then it will observe what is happening again. So this interaction will be a loop. So that's exactly what we see in this framework. So this is the framework is very high level. It will become very useful in the future when we try to train agent. Right now, we don't have the notion about how to improve the agent, how to fine tune an agent. Mostly the work is done in the large language model fine tuning, but agent fine tuning is still very early. We haven't done so far. It's still very ad hoc. The but you but to give you really the under hood inside the agent, what we are actually right now everyone is building essentially is the capability of certainly this agent interact with environment, take action. So the action goes out of this big box. What it comes in is the user input, the context. The context could be the current user conversation, the current code, whatever the agent observes. The agent takes everything coming in, then do a reasoning. So the reasoning can we will talk about different reasoning method. There is a so-called self-reflection. The agent just has a self-checking. If it generates some output, it will say is it correct or not. If not, it will continue to generate this next output and go out to do another round of conversation with either with the large language model or with the outside. So that's the reasoning part. From the reasoning, the agent will generate a sequence of actions. Sometimes it's one action, sometimes it's a sequence of actions. And we'll see. I have one example where a travel agent it can do a sequence of actions. So we can actually build that in. Now, if those sequence is predefined, if it's very rigid, like first you have to do this, second you have to do that, then we call it planning. So we have this so-called predefined plan. The agent has to, for example, say an email agent. The email agent has to digest the email from the from someone sending. If you are writing a response, you need to understand the sender's intention, understand, so digest that in, and then writing the email is the second step. So the two step has a sequence. In other cases, they don't have a sequence, so you can parallelly doing all the actions and then combine the result. And for each action, we will call a certain tools. Now, all this sounds kind of a little abstract, but it will become more clear, and particularly when we have the code. Now, in the reasoning, I mentioned about the self-reflection. You can put a prompt, say, do a chain of thoughts, reason step by step. So that we found that we basically the whole field find that make it agent much smarter. And self-feedback can also be put in the prompt. You can say, once you generate result, think whether the result is valid. If not, continue to generate the next response. So those self-feedback can also be put in the prompt. The third part is using external feedback. So with external feedback, what we can do is we call external tools. For example, if you are writing a coding agent, you can simply call the OS, call the current uh, the operating system to let it execute the code and see whether the result is correct or not. Or you can call certain kind of knowledge base to do verification. So with external feedback, the agent can do internal several rounds before generate the final answer for the user. So you can keep criticize yourself, do verification. So this is very useful if you want to make sure your result is correct. So if we put this whole thing inside a framework, inside the agent design, essentially, so we have this. So what I just described is one so-called internal evaluator. So this internal evaluator is called self-reflection or step-by-step. The external feedback is coming. I mentioned all the external tools give you the feedback. On top of that, we also have a so-called short-term memory and long-term memory, and those can be saved in the database. That can be also saved in the certain files or in the current RAM. For example, the conversation short-term memory include all the previous conversation in the current session. So that is the short-term memory. The long-term memory, I think is more interesting, is after every episode, after every conversation, you save, you create a summary or save certain kind of entities, certain kind of specific topics into your database. So next time you will refer to that when you talk to the same user. So your memory will be corresponding to the particular user you talk to. And finally, you have this actor here. So this is another way to visualize the components inside the agent. So for action, I want to talk about the most important, the most interesting part for us to look at agent is this so-called tool use capability. So since there are only a few companies nowadays doing the large language model, the remaining the whole world, essentially all we are left to do is to build agent, and the agent essentially complete a certain that can complete a certain task. So in this very simple example, this agent, I didn't, we will see. This agent has some reasoning inside, but most importantly, this agent is trying to look at a video and answer question from the user. So the agent can cause a tool to, so if you look at here, right now actually Google already deployed this with a camera. With Gemini, you can look at a scene, just turn on the video, and you can talk uh, to this agent. Say what is in. You can ask a very complex question. So the Gemini right now is doing simple object detection. Say what kind of flower, what kind of um, monument, what kind of building is this? Where are we? So it's a very simple, I would say simple recognition, scene recognition, but you can build more interesting understanding of so for example, here, what's the relationship between this boy and this adult? So the agent can have some reasoning, as I mentioned, you have some self-reflection. So who basically give itself a instruction, a step-by-step instruction. Say I need to find out, first segment the video. After that, then it calls a segmentation tool externally to complete the task. After that, it will do a second tool, called the second tool to do visual question answering. So all this is a sequential tool that's been called and achieve the final goal to answer this question. So it's a step-by-step, self-guided answering. And that is what a simple, very simple agent you can build um, with there are many online tools, so you can just write a prompt. The prompt will give you this so-called self-reflection, and then you call several tools, and we'll see how the code is done later. But that is the high level of a simple tool use agent we can build. As I mentioned, the tool use agent has this sequence of steps. So we go from step 1 to 2. There are many times we call of so-called trio of action. So for example, for software development agent, it may need to write code, but also need to fetch certain kind of data or process the data. Maybe simultaneously you may do several things. And so one agent could wait for another agent to complete a certain task. Or inside this agent, you can think about it's essentially is different task needs to be completed that can be done parallelly. And in that case, how we navigate the tree and how the agent to decide whether to wait for the previous action or continue just actually execute on all the parallel on other actions. Those are there's a lot of work recently been done on that part. So uh, I I want to use this example as as an illustration of what is like to have a full-fledged agent. For example, suppose someone deployed this so-called OS Copilot. So suppose you have an agent sit on your laptop. It essentially interacts with all the OS system. Essentially can open your file, can make a recording. It can monitor your your keyboard, your keystroke. Essentially learns about your action or in the day, right? So that's it. It's a very powerful, potentially powerful agent. So this agent has several components. The components, first of all, it has a planner. So planner means if it tries to do something for you, it needs to have a sequence of actions. And those actions could be so on the right side could be interface with the internet, with API, with your OS underlying system. In the meantime, it also needs to have a memory. So we call working memory. It has, right now we basically divide the memory into, people divide it into three types. So here it shows the two types. One, this is semantic type. Normally it's called a fact. So it's stored in the database, it's stored in the document. So this is a kind of memory the agent needs to use to do certain things. If suppose user has a question, user want to say, what should I do to say to like delete certain files, right? So if they don't know the command, the agent is supposed to be able to retrieve that information. And secondly, is another is a so-called user profile, and this is not fully a fact. It's a summary from the user. It could be a general description about the user, but it could also be the user's action, user's previous interaction. And then we have a so-called procedural memory. Procedural memory, you can think about as the system prompt or high level understanding about all available available tools, or how the agent should act in certain environment. And so that all this so-called working memory, combine that with the working memory, that becomes part of the agent environment. All right, so that this is more high level view on the. I will get into, let me see, I have one more slide. Okay, I have two more slides. So besides this, so a full-fledged agent has all these components. We know each agent does a certain task and become very complex. For example, a travel agent, you can say the travel agent tells you how to plan for different locate attraction, different cities, different route. But then there's you also need to book hotel, book flights. The If one agent is waiting for you interact, it will take a long time. So why not just let another agent fully taking care of the booking? So that agent is fully defined on one specific task. So multi-agent system become very popular, mainly because uh, ideally, potentially you can list all the tools in the one big list, but it becomes very complex to manage. So by dividing, specialize, make different agents specialize doing different things, it's easier to manage the task. So essentially, multi-agent system is just a high level a way to organize the task in a more modular way. That's essentially what a multi-agent system is. It allows parallel execution on different tasks. And it doesn't matter whether it's called certain names. So the name doesn't matter here. In fact, if you look at the OpenAI agent has different kind of names. Hugging Face has different names. So the name doesn't matter. Essentially, all you have to remember is that there needs to be a central planning agent. We call the main agent. So the main agent is the one who does planning. It coordinates all the rest of the agent. That's it's like a person has a brain, a central brain that commands all your limbs or the arm and the legs and the other part of the body. So we still need a central brain that is the main agent. And then other agent, they could be parallel, they could be hierarchical. Really depends how you organize. And that itself could involve some special design. But for today, I won't go into detail in that part. Now I want so also I want to show you some actual agent applications. And later, if we have time, we can talk about how we actually go about to build such an agent. The as for on the software side, what you can do is the agent can take input from the user. It has some internal system command prompt. The user says, "Oh, book a reservation for me in a restaurant." So the agent goes out to the website. It processes the website, then create some action proposal. Now this is internal critic. This is self-evaluation. So it internally generates three possible actions. It then analyze itself, say, is this the first action I should take? If not, it then propose more actions, maybe do additional search, propose other actions. So all the things on the right side is the internal happening with the agent. But once you do that, the agent actually can take action on the website, can make a click, and then and enter certain numbers. All this can be done by the agent automatically. Another type of agent we call so-called purchase agent or e-commerce agent, where the agent can actually visit a e-commerce store to buy something. And the way we think about this is agent has certain action to take, and they observe certain state. The state are the website or the text on the website, the user request, and so based on that, those state, how should they take action? What kind of action they can take? So this is another application for the agent. The third one I want to mention is so-called you can create a so-called machine learning agent, where we can essentially automate a lot of machine learning tasks. Where the job of a machine learning engineer essentially is fine-tune the model. So this is a classical machine learning model where you do feature selection, you do data selection. But even for the future, for like a deep neural network optimization, fine-tuning, you can write an agent that does this, essentially take the data, do a training, then update the parameters of the neural network, do fine-tuning, do test, and then iterate again and again. So this whole thing essentially can be automated, and then essentially that's an agent. We can call that a machine learning agent. So to summarize, essentially the fundamental capability of the agent is reasoning, doing chain of thoughts action, using the tools, and action combined with reasoning called the React. And now React becomes very popular in the agent design. So almost I think a majority of the agent today is designed with React prompt. Basically, ask the agent to reason, take action, then think step by step and take another action. So you can give the so-called React prompt to the agent for them to reason about. And we talk about the planning. We also talk about the multi-agent interaction. So that is the high level in the more like a framework overview about the agent. And now before I get into the code, I want to answer some questions then, and also to just one moment. Let me see if I can enable the voice. People can actually unmute. And also I will answer some questions. Okay, yeah, thanks. Yeah, Pushika, you can unmute yourself. Yeah,
Oh, thank you, Julian. Julian, quick question for you is regarding the planning stage.
yeah.
Is it usually a one plan that it goes after, or does it do simultaneously multiple plans as well? And are those done in parallel? Thank you.
Planning normally is in the beginning. As I mentioned, planning can be done in different ways. So many simpler way just to do one plan. You have that in the beginning.
Got it. So you take your best shot and then go down that.
Yeah, yeah. It's a very linear way to define. It's not too complex. The reason what I'm saying that is today's agent, we are still in the early stage of agent. I think going forward, when we do very complex interaction with the user, probably the planning will be more complex. So far, we haven't even crossed the bridge of building very complex agent. Well, of course, we see the coding agent are very interesting, very fun. They typically have very well-defined structure in the back. But once you get into more complex daily agent, like monitor your email, write email for you, interact with other people, those are very complex. I think we haven't reached that yet so far.
Thank you very much, Julian.
Sure. Thank you. Another question in the chat is how do we map reward? So the reward is there are several ways. One is you if you execute, suppose you're a coding agent, your code runs, then you get a positive feedback. If it doesn't run, you get a negative feedback. So you can actually build a reward system. You can also use a large language model as your judge. That's a second way to do. Or the third part is get a human to give you feedback, some down, some up. Okay, so I will. Okay. Any tools? Yes. Good question. Personally, I think right now there are several agent frameworks. There's LangChain, LangGraph. I just mentioned a few. LangChain, LangGraph, small agent, SMOL agent from Hugging Face, OpenAI agent, and Crew AI. This is at least five you can use. I think from my viewpoint, because I personally feel LangChain, LangGraph is a little rigid. Particularly, not everything can be described in a like state graph, node between nodes. Those are very that I think it's old ways. When we build like a conversational system, we use a graph before large language model. So graph architecture is quite limited in a way. Jim, do you have a comment on that?
Yes, I was just wondering, I've seen several talks on agents, and so far they've been pretty unimpressive. They basically just did something that ChatGPT can already do, like reading a web page or something like that. And so I was just curious, what is the most impressive real world agent that you've seen so far?
Like a windsurf. You can write one command, they build the whole game for you. That's
Okay,
agent, right? Yeah. They created the whole repository. And all those coding agents are quite impressive.
all right, thank you.
Yeah, yeah. So you cannot do that right away. All right. Maybe I will get into the code first. I will come back to the questions because so far people still think it's very mysterious. I think a majority, even myself, in the beginning, I look at all different framework. I can certainly write agent code using those framework, but they are still mysterious, right? They didn't tell you exactly how the agent was built. So I want to actually take you under the hood to go from we build agent from scratch instead of actually using any of the framework. Like let's just build one just based on OpenAI API. That's all we have to do, and then we can make the agent become more and more complex. That's I think that way you would understand how the agent was actually built. So let me actually share my screen. Let me. Let me see how we can. Okay. Terminal. I want to share. Actually, let me just share my whole screen. You can. Let me share my whole screen. Doesn't allow me to share the whole screen. How do we? Oh yeah, desktop. Okay. Let me just share the whole desktop with you. And so it's easier for you to see exactly. So first I want to share the code. You can see the most simple thing. So when we say agent, many of you have built the agent with OpenAI chatbot. So the first most important component of agent is this loop. So when we say agent is constantly interact with the user. It's not just one round interaction. So if you are building something just one round with take a user one command and finish, it never come back to improve, then it's not really an agent. It's more like a tool, a more. Say, for example, one time we thought about building a podcast. We call it agent, but it turns out it's not an agent. It's a podcast tool where I can convert a person's a paper into a podcast. So that is a very interesting application. It's an app. So an app is not an agent. So number one differentiation is what is an agent? What is an app? The agent is something interact with the user. So this is the fundamental part. Now, after that, we will call this a tool agent. So notice that this is a continuous loop. So this is the basic part that I want to. Now, inside of this tool agent, let me explain what is the most fundamental. I will actually delete this. Don't want to confuse you. The most fundamental part is all the agent today we were talking about is driven by large language model. So essentially, the large language model. I also delete this part. Make it very simple. So what does the agent do when they receive a user command? Is they formulate that into a message. This message will be sent to your large language model. So whether it's OpenAI, whether it's Grok or Gemini, or whether it's your local Llama 3 or DeepSeek, they all use this similar kind of format. The format is, first of all, you need to have a system prompt. The system prompt is describing the whole thing, the task. Who is this agent? So normally you give the agent a role, say you are an information assistant, or you can say you are a travel assistant. So the major role is defined in this system prompt, and this is belong to the system. That's number one. Number two is you interact with the user. So you have a user content. This certainly come from the keyboard, from whether it's from your phone, from your speech, doesn't matter. Essentially, that is the content coming from the user. So this two is the information you will send to the large language model. When you send this to the large language model, the language model will give you back a response. So this response is very, let me describe this function. This function is very simple. This function essentially right now, I'm calling OpenAI API. See, it's a very simple. So all the trick of building agent essentially is what you are sending to the large language model. It's very much like a RAG, right? In the old days, the RAG model essentially is you combine your documents, you retrieve. First of all, you take a user's input, you do a similarity match with your documents. You select the top 5 documents. You attach that, add that to your context, then send all of them to the large language model, and then receive the answer. So that's the RAG. That's what we already know. You can use the RAG to build a customer support, to do FAQ. That's very useful, very interesting. But the agent, now I'm talking about a core additional tool, which is not a content tool. It could be a functional tool, and that is more interesting. So, so here the most important different part from RAG is this part, the tools. So, and you see here how we, what kind of tool we can use is certainly okay. So actually, let me slow down a little bit. So I want to make this more interactive. Any questions so far until here? You can unmute yourself. Yeah. If there's no question, it's clear, I will continue. Hello?
Yes, Julian, just I think this is the place where you stop, but here you define tool is equal to tool. So can you tell us what that?
Oh, okay.
What that
So,
constant
okay,
is?
here. So the most important part, if you want to build a tool calling agent, you have to have this dictionary. So in the dictionary, you define the tool you are going to use. So for example, one tool is getting search internet, maybe using my own local tool to get current weather. This look up sales data, use my local database or use my document. So the tools is defined by you. So if you are building anything interesting, you need to, this is what differentiate each different agent. So coding agent calling a coding tool or doing their internal tool. And essentially all this tool will be defined by your function. So this is a classical software engineering. Is where you define. Right now, I don't have a very complex tool. In fact, you can add a SQL selection, whatever here. We'll do in the later part. But what I want to show in this part is defining the tools and the corresponding actual how to execute the tools. So the function is defined here. And each tool requires certain arguments. So if you don't have those arguments, you cannot execute those tools. That is just say required. So when you said, so this
Since the parameter type is object, I assume it's taking a JSON string as its input to the tool.
That's right. Yeah. Yeah. So so this whole thing will be sent to the large language model, so that the large language model will, based on all the string here, to reason about whether to match the user request to a certain tool. So the actual work is not done by us, it's done by the behind the scene large language model. So it's essentially they figure out whether they should call the tool or not. Essentially, we don't have control. It's not like in the older days, people say you do if else. In the agent, in the large language model based agent, we don't have control when and how we are going to call certain tools. That is determined by the large language model. So it's determined by the answer here. So right now, when we send the request to the large language model, so this client is the OpenAI client. When we send this definition of the tools, they will determine when they come back. So here this is the step. so the answer from the large language model is defined in here, message. So the message, I will show what a message is. We can print that out. Yeah, actually, I should not delete.
Julian, before you go
Yeah.
there, can I ask a rather quick question?
Yeah.
In the tools dictionary that you have up there, there's a section under each function that you have called description. And is that
Yes.
something that you're trying to give
Yes.
as much information to the LLM model? So
Yes.
that's the description for the help of the LLM model?
Yeah. So this description is the most important part. So if the user, for example, mentioned the weather, because the tool has the weather in here, the LM will reason whether this fits into here, but they also look at the context, whether there's a city there, right? So the LM will use this description to decide to call this tool. So when the LM response comes back, it comes back with the words plus the tool it considered. So this is what we send. This is what we send to. This is the second round of question. Forget about this. Okay. Let's look at the main loop. Divya, go ahead.
Yeah, so when we say required as city, does because it's an LLM, will it also understand context? Like say a country was given or like a more local region was given, it would automatically understand that as the required, right? Or is it more rigid?
Yeah, LM could certainly make a mistake. So if they make a mistake, for example, the tool comes back, even though user ask the weather, the tool comes back, they don't have the weather, they didn't call that tool. It's possible. So our goal in defining, so this part is very crucial for what we. So in the description, we should be as descriptive as possible. LM is very smart. Yeah.
Because when we say city, even for the city, there's a description. So if we want to add something more generic or more specific, we have to describe in the description is where we have to provide more details.
Yeah, you can. Yeah, this is a very simple. This is like the beginning, very beginning, simple example. Yeah, definitely. We will see much more complex in the open Manus. In the Manus tool, they have very complex description. Yeah. But let's slow down a little. Let's just like get the first most simple one working to understand the whole flow. The flow is like this. User,
Can I ask a quick question, follow-up question? So
yeah.
What's the difference if we send temperature equal to 0 and temperature equal to 0.5 here? So temperature 0, normally we say that's more accurate, but it's deterministic. But if we say that when we send down the message to use temperature higher, it means that we are not match the description accurately, or
Temperature 0 means no variation, right?
yeah, I know. Yeah. So if we set higher, what's the impact?
Higher means you want a more artistic, more fun answer, right?
Yeah, I understand. So it will be better or worse for
For tool
mapping
calling, I
itself.
would make it 0 because you want more rigid.
Okay.
Yeah.
Okay, that makes sense.
Yeah, because this is more factual. You are doing factual things. If you are not doing factual things like writing a novel or writing a poem, temperature 1 or 0.9, that's all fine. And so the major things we introduced here from traditional chatbot is tools, and this is offered by all the large language model. And so essentially, as we can see, we are very much dependent on large language model. Essentially, the large language model is the foundation for everything. You cannot live without them. They are like electricity in the future. So we are just like the second tier on top of that, more like application. Agent is application. It's a specialized application of a large language model. That's called this way. This is why also it's very dangerous. Not dangerous. Essentially, on business viewpoint, OpenAI and all the company, Google, essentially will, because they see people how to use the tools, they will build in all those tools inside their large language model. So now if you go to ChatGPT, you can see they can do travel planning, they can do a map. They even now have a map. They have, so they gradually pull back all the tools into their own functions. So I think for people who are building tools or building agents, we have a very short window, maybe 6 months, maybe a year. But after that, all the current LM providers, they will do all the agent. Essentially, that's that's what I think.
Okay.
Yeah.
So because I have a use case like this, right? So if
Yeah.
I want to build agent, recommend the birthday gift. If I set temperature equal to 0, probably the agent will be always recommend the gift, birthday card. All right. So if you will not like recommend other things, more imaginary like a watch or like a jewelry or something like that. Would that be the case?
I'm sorry, can you repeat the question?
So if I want to build an agent to recommend the birthday gift, right? So if
A
I want
birthday gift.
yeah, something like that, right?
Yeah.
So this kind of thing, you need to have some kind of imagination too. If you set temperature to 0, probably you will all recommend all the time is birthday gift card.
Oh, no,
Something
no,
like
no, no.
that.
This
No?
temperature is referred to large language models response from
Okay.
ChatGPT.
But you will
Has
call
nothing
your
to do
agent.
with your answer.
Okay, you will call this agent. You will not
This is
recommend.
not agent. This client is OpenAI. This is large language model.
Yes,
Your agent is here called a tool agent. This is our
yeah.
agent.
Yeah, I mean, if you send pet to 0, you will guarantee that this question is trying to recommend a birthday gift, and it will call your agent, call your function, let's say, right?
No.
No? Okay.
Temperature here refers to how the large language model would give you answer. The answer has nothing to do with the content. It's just one specific way to generate the whole sentence. So
Oh.
sentence as a sequence, they say certain word first, they say another word after that. There's a sequential generation. That whole sequence is very fixed. So if second time you talk to them, they will speak the same way. They will never change.
Okay, got it.
That's
got
what
it.
it means. Temperature equal to 0.
Got it. Thank
Yeah.
you.
So here, now we understand we are sending the tools, we are sending the definition of our tool to LM. So when that comes back, we will check whether this is empty or not. So the LM comes back, will have this subfield called the tool calls. So essentially all the other agent, agent framework are built on top of this. The tool calls tells you whether the weather is being called, right? So if there is a weather tool being called, we will actually handle this here, right? So we will handle tool call. Handle tool call basically just match the tool name. Where's my handle tool calls? Handle tool call, you define that here. You just match the function name with the tool name. So we basically define the name of the tools. So for example, the name of the tool here is get current weather. Then we are going to have a function exactly the same name. And so when the agent comes back, when the ChatGPT comes back with say, I'm calling the tool get current weather, I'm going to call this function. So essentially just a function mapping from the name of the tool to the actual definition of the function. So here is the tool function lookup. Yeah, that's it. So this is a convoluted way to say how we build the tools. And then let me just show you the demo. Let me actually open up a new window. So in this, I have agent tool course. So I'm going to so now I can say, how are you? And so the agent comes back, and the next time we can try again, you will see whether the answer is the same. So there's no weather, right? But if I say, what's the weather in New York? Now it actually it calls the temperature 15 C and say partly cloudy. Now if you come back to the code, you can see here I defined the tool. I defined the tool inside the get current weather. I actually put down this attributes here, right? The of course, inside here you can do a web search. You can take the city name and go out to do a search. But what I'm illustrating is it's actually calling these tools, and then you can, yeah, if you say other things, say okay, so this is a different one. So it goes back to not calling the weather. This is a simple example to show you the actual tool is being called. Okay, and so I'm going to quit here. This is one thing I want to show you. The second thing is I want to show you, besides calling the tool, you can make it more complex. The complex part is you can search for like a database. So here I'm defining search_db here. Search_db basically we are going to load a document. The document is a JSON file. And you can think about this is your local knowledge base. You can think about this is your basically you are searching inside this document. And what we are going to do is we have a document that I'm going to show you. Very simple. You can have a much longer, but essentially this is customer support. The inside here you have question and answer. You have what is a return policy. This is different from the RAG model, slightly different because it's calling the specific. I know which document I'm calling and how I'm going to only match the user query to a specific item. This is more like a database retrieval. So here in this our tool will become more complex. You can see now I have get current weather, search web, use my computer. Now you can do you can call the OS, do some other things on your computer. You can search knowledge base. You can also look up sales data. So now I defined 5 different tools. Essentially, it's up to the large language model to figure out which tool. They could be confused, right? So that could be the danger here. But the whole thing, as you can see here, for corresponding to every tool, you have a corresponding function. For the first tool, you have this function. For the second tool, you have this function. So you define corresponding function for every tool. And you have a function lookup. Essentially, this is a dictionary lookup. And the rest is the same. You send the tool definition. You send the tool definition to the large language model. When it comes back, if you actually see, yeah, if there's a tool call, if a large language model recognize the user query, user intention matches one of the tools, they will call the specific tool, right? So let me actually run this here. So here, let me say, so I'm going to call run this new agent called the knowledge base agent. So I'm going to say the same thing first. As you can see, because the temperature is 0, the answer is identical. It never changed the answer. But now so I have a different questions, right? So now I'm asking, what are your return policy? And I'm actually printing out the tool call argument here, but the answer is, this is answer from the agent, right? So this answer is exactly defined in our knowledge base. I can show you. So in the knowledge base, it says 30-day return, 30-day purchase. So here, it says but the large language model wrap the knowledge into their own conversation. So the reason they can do that is in building the agent, let me show you. We send, if it's a tool call, we send back the retrieved. So we actually retrieve from knowledge base, which retrieve the content from the KB and send it back to large language model to generate the second round of answer. So this is how it comes back with a very nice answer with the new knowledge.
Junling,
Yeah.
if we said, tell me your return policy instead of what is your return policy, would it have still matched?
Yeah, sure. Let me show you. So you are saying, tell me your return policy, right?
Yeah.
It should. Yeah. This is quite smart. That means they were able to identify. This is why using large language model is very powerful. It's very smart. It can match variation of sentence.
Now, Julie, for this examples that you're showing today, what is the size of the large language model that you're using in the background? Is it like a 4 billion parameter or is it larger?
Yeah, I'm using 4.0 mini.
Okay, thank you.
Yeah. 4.0 mini is not expensive, but certainly you can do Llama. You can do DeepSeek too.
You said in your code you have taken the message from your knowledge base and you're sending it as part of the request call. How is it different from what we do with RAG? Even in RAG, given a user score, get the top 5 and put them in the context. Here you're getting maybe the whole knowledge base or part of a knowledge base, or
You're right. In this part is the same as RAG. In this part is the same. But it doesn't. It's using a match. It's using a tool call match. So notice here, we are doing this search knowledge base match, right? We're doing a function call match. In the RAG, you always, regardless of what the user says, you always try to, so it's very expensive in RAG. You actually, regardless of what they say, you always try to do similarity match. Always take the top 5, right? That's what you do in RAG. But here, you depend on what the user says, depend on what the user is doing. You sometimes search the knowledge base, you sometimes don't. So you have a choice of whether use a knowledge base or not. Yeah.
So, okay. So then you have asked a different question. Instead of asking what is the written policy, you said, tell me the written policy.
Mm-hmm.
The search KB is just a function. It is going to take that question, right? Same, tell me your written policy. How is it able to retrieve the same answer then?
Then that's done by large language model. So they do the same tool call. So regardless your sentence pattern, the large language model returns back the tool call equal to search KB. So you always call this function.
Oh, okay. So based on the question, it has figured out that any policy related questions go to search KB, basically, right?
Yeah, yeah. That is done in the large language model response.
Got it.
So when they returns back, they give you the tools to call. Yeah.
So you asked a few minutes ago, you said that in a year, all the tools will be built into the large language model.
Yeah.
What's to prevent them from simply searching their GPTs and copying and building them in, building the popular GPTs into their model?
GPT into the model. Who? They, who is they?
Whoever's building the model.
You're asking whether models will call other models?
So I'm asking whether in a year, all the work we do on GPTs today that are popular, all the agents we build will be stolen and put into the model by the company that creates the model. In other
You
words,
mean the foundation model,
yeah, basically, it seems to me we're doing the work for the company.
Yeah, that's true. In fact, that's what's happening, right? You see the ChatGPT now. Actually, I want to show you for travel itinerary.
That's not unique to this. You know, Microsoft for a long time has built in the features to Windows that was the most popular add-ons to Windows. Oh, everyone's downloading zip. Let's make File Explorer zip and unzip things.
Well,
Yes.
the difference is that they can see our code. They can see our GPTs because we're putting it up using them. Whereas if we have a C app, then Microsoft at least has to engineer from zero.
That's why enterprises tend to use open source models. Yeah, all these big companies, whatever you're querying, they're learning from that and they're enhancing their models. And there is also, I think, ChatGPT by default doesn't allow you to not use your data. Whereas, for example, Claude by default doesn't take your data at all. Gemini has an option to flip. By default, it is on, but you can go and flip it. OpenAI, on the other hand, it doesn't have the option at all. So these are things that we should read. And if you really are concerned about those things, I think you should not use maybe GPT, use Claude.
Well, I'm not sure you can trust it. Meta's already been caught stealing copyrighted work from others.
There is a setting within ChatGPT that specifies if you've got the Plus account, for example, that specifies whether it can train from your sessions.
I understand. So my second question is, in terms of a context window, is it always best to pick the shortest context window that will do the job?
What the shorter context window?
Well, the amount of effort, the order of how long it takes a process to complete doesn't grow linearly with a context window. So should I always pick a 1 million context window, or should I pick the shortest one that I can that will complete the job? Do you
The
understand the question?
shorter, the less expensive because each token will cost you. So the smaller window, you will cost less. Otherwise, they will assume you send in 1 million. Of course, they will use the actual token, but yeah. So as you can see, I'm trying to show you how much function already built into the current large language model. They have map, they have hotel booking. Essentially, they are moving toward the agent now. But the usability is still not as good as the agent because it's less personal, right? So this is nice, but not it's okay, but it's still not as interactive as it should be. Let me show you the agent I built. a travel agent, just for fun. This is a simple, but it's more personal. It's like I'm talking to someone, right? So say I'm going to Paris. Yeah, so it's gradually let you give preference, and so let me show you.
Julie, while you're
Yeah.
showing us this demo, a quick question is, how is the agent prioritizing the tool versus prior knowledge? Does it always first look through the tools to find the answer? Otherwise, it uses its own memory, or what is the priority on using or skipping the tools?
I'm sorry, can you say it again?
Yeah, how does it prioritize whether it's going to use the tools or its prior knowledge? Or does it always first go through the tools, and if it's not happy with the answer, only then it goes to its prior knowledge?
That's part of the reinforcement learning is it's
Well,
been
well,
answering questions where in scenario A it uses the tool, in scenario B it doesn't, and then some human says, I like answer A better, or I like answer B
You can,
better.
in the prompt, you can
Friday
give
night
a more
sale.
specific request. Yeah.
I know you can see another
So personally, I think there are certain room for
That's
the
where we're on.
okay. So the OpenAI answer is it's interesting, but not that targeted. It's coming, right? It's, as I mentioned on this part, the travel part, they are doing very good job. Still not personal. There could be better. So there's a little bit of room. There's more room for a small window for people to build. I know several startups doing travel agent right now. Let's see what else I should say. Of course, you can also, if you are more interested in more fun stuff, you can control your computer, like OS. Essentially, if you know the command, like here, what I did is you can put in all the OS run, do the sub process, anything controlling your computer to do things, even like save certain files, doing you just by writing those commands. Essentially, you can create your own agent for yourself. You can also write an email agent for yourself to like reply to people. There's a like online course regarding how to build an email agent. So there are many things you can do. Yeah. Okay. Question. Sorry.
Hi, Junling. Thanks for sharing. I have a question. So if my question needs multiple either tools or sub-agents to return data, and then I need the top agent to do some synthesis and
Yes.
return like
Yeah.
a synthesized
Good
result from
question.
multiple
So
tools.
basically,
Yeah.
you are asking about a multi-agent, right?
Yes, and so actually my question has two parts. So one is it possible? Like it has some sort of interaction between the top agent and the sub agent, and sometimes it may be multiple agents to give questions back and forth. That's my question number one. Question number two is for a business scenario, I might need to teach the top agent to pick what agents to ask and answer the question. And also I might need the top agent to actually have different ways to synthesize information. Because in terms of a scenario like hypothesis generation and validate hypothesis, then they need inputs from multiple sub-agents that return data. And then a top agent or another agent can use those data to synthesize a result. I know it's a complex case, but just curious if that's a possible use case.
It's both been done. This for top agent to synthesize information, you put that in the prompt. So your top agent has a very clear instruction to say synthesize from every other agent, essentially in the description. The multi-agent interaction. Oh, actually, let me show you. Let me unshare. Let me show you the multi-agent part. multi-agent, there's so many multi-agent, so actually I don't need to, like a crew AI, let me see if I have example. Wait, CFL code. Okay, I have a crew AI demo. Let me see. Let me share the screen. Okay, let me just share the whole laptop. So first, let me show you the OpenAI agent. OpenAI agent. No, actually, let me go to. Okay, so here there is an OpenAI agent. Let me. So here is so-called multi-agent. One is a handle. This is the simplest example, but very clear to observe what happens is you have a so-called triage agent. The triage agent is the core, the center. So now we abstract out. We have the general definition. We use the definition of agent. This is just a wrapper, essentially wrap around the OpenAI client core. So this is so-called the triage agent is the main agent. It decides. So it has a function called a handoff. The handoff will allow you to call other agents. So whether it's a Spanish, English, it could be say research agent, report agent, or financial agent. You can put a different agent definition here. And in here so you see the whole loop is still the same. Everything essentially is a loop. In here, all you have to do, you are just calling the triage agent. You call the main agent. And then the main agent delegated the work to specific agent to do. So right in here is a multi-choice, but you can potentially have like simultaneously inside you can have like a manager agent who does additional several agents doing things. This is a simple way to hand off and then comes back. The coordination is not that complex, but there are more complex example. This is just to show you how multi-agent. Let me see if I have the crew AI. So crew AI is the major. Let me see if I can actually get this run. Yeah, this should run. Okay. Yeah. So this is a research assistant. This research assistant, you can ask, say, research the latest AI agent news in the last month, and summarize them. And we will start a search, and then you have many agent crew started to do the job. Make this smaller. You can see this is a research analyst. You have this is also research. So yeah, it comes back with the key finding. What's the major news? Major findings. Jen Spark, super agent, employs 9 different LMs, over 80 tools. Wow. Market trend, statistical data detailed. So here I want to show you the code. So then you can see. Cut this. See. Oh. Okay, so if we look at the, in fact, I was a little disappointed. There's not many multi-agent here. So let me see. In this here, you have research agent. Let me see where's the main function. Start research. So they have a researcher. They have different roles. So they have a researcher, create a researcher, and there's a data analyst. Yeah, so here. So they have a researcher, research task, run, and then inside the source, they have what? They have a researcher is an agent. Do they have other agent? This one maybe they did not. But you can imagine, you can dedicate this task. Certain people do analysis, certain people do summary, certain people do, yeah, there's a crew. You can have a, so here, the crew can have multiple agents inside. So you can definitely put a multiple agent in here to coordinate. And the crew AI has certain ways for the agent to communicate. So it's written in their protocols.